So, have you ever looked at a massive piece of software? I mean, something with millions of lines of code, and just wondered how? How does that not just collapse into a complete chaotic mess? Well, today, we're going to pull back the curtain on that, using Python's amazing organizational system as our guide. Right, this is the big question, isn't it? It's like trying to build a life-sized Lego Death Star. You can't just have a giant pile of gray bricks on the floor. You need a plan, you need instructions, you need little baggies of sorted pieces. And that's exactly what Python gives coders. It's a system for managing complexity.
So, where do we start? We start at the very, very beginning. The absolute smallest, most fundamental building block. Pretty much everything we're about to talk about starts with one simple but incredibly powerful command.
You see this line right here, import math? It looks so simple, but it's basically a magic word. It's you telling your program, hey, go get me the toolbox full of math stuff that somebody else already figured out. And just like that, you get access to tools for square roots, for trigonometry, all without having to write a single line of that logic yourself. It's the ultimate don't reinvent the wheel command. So what exactly are we importing when we type that? We're importing something called a module. And honestly, it's not as complicated as it sounds. A module is just a Python file. That's it. It's a single .py file where you've stored a bunch of related code, like functions and variables, so you can use it again and again. And this is where our Lego analogy really kicks in. Think of a single module as one unique Lego brick. It's got a specific purpose. Maybe it's a 2x4 red brick, or maybe it's a special little transparent piece for a window. It does one job, and it does it really well. Okay, so we have our individual bricks, our modules. That's great. But what happens when your project starts growing, and you've got hundreds or even thousands of these bricks lying around? You need a way to organize them. You need some containers. Look, if you're building a tiny little Lego car, maybe a handful of bricks is fine. But when you start building that massive Death Star, just having more and more files dumped into one big folder is a recipe for disaster. You can't find anything, you don't know how things connect, it's just chaos. We need a better way. And that solution is what we call a package. A package is, at its heart, just a folder. But it's a special folder. It's a folder designed to group a bunch of related modules, a bunch of related Lego bricks, all together in one tidy place. It brings order to the chaos. Let's look at a real example. See that e-commerce folder? That's our package. And inside we have our modules, our bricks for things like billing.py and shipping.py. But you see that weird little file, init.py? That's the secret sauce. It can be completely empty, but just by existing, it tells Python, hey, this isn't just some random folder. This is a package of code you can actually use. So to bring it back to our analogy, if a module is a single brick, a package is like a themed Lego set. You know, like the Lego Star Wars X-Wing set? It has all the specific wings, cockpit pieces, and laser cannons you need, all organized together in one box. That's a package. All right, so we can build our own modules and our own packages, our own bricks and our own themed sets. That's cool. But here's where Python gets really powerful. What if I told you it comes with a massive box of Legos for free right when you get it? I mean, why build something from scratch if the perfect tool is already sitting right there waiting for you? Python has this philosophy called batteries included. It means it ships with a huge collection of pre-made modules for all sorts of common tasks. This giant collection is called the standard library. And this is just a tiny taste of what's in there. You need to handle dates and times? Import datetime. Need a random number? Import random. Need to work with files and folders on your computer? Import OS. These tools are battle-tested, reliable, and just there for you. Now, as amazing as the standard library is, that's still just the beginning. The global community of Python developers has built an ecosystem that is, well, it's mind-bogglingly huge. We're going from the toolbox you own to an infinite global Lego superstore. And the key to this entire superstore, the key that unlocks the door, is this one command, pip install. With this, you can download and use packages built by developers from all around the world to do practically anything you can dream up. And when I say anything, I mean it. Look at this number. Over 470,000 external packages. That is nearly 500,000 specialized Lego sets available to you for free. You want to do complex data analysis? There's a set for that. You want to build an artificial intelligence model? There are dozens of sets for that. It's the power of community, and it is incredible.
And here are some of the all-stars, the legends. Building websites? You're going to hear about Django and Flask. Doing data science? It's all about pandas and NumPy. Diving into AI? You'll be using TensorFlow or scikit-learn. These are the industry-standard toolkits that power huge parts of the modern world. Okay, let's take a breath. We've got our single bricks, our themed sets, the built-in toolbox, and the global superstore. Now, let's put it all together. Let's see how a real program gets built by combining all of these pieces. So here's our mission. We're going to write a quick script that grabs a user's profile info from GitHub. And to do it, we're going to import tools from different places. We're grabbing requests from that global superstore, and we're grabbing JSON and datetime from our trusty standard built-in toolbox. We're mixing and matching.
Step 1, we need to actually talk to the internet. We use the requests library for that, the one from the superstore. This single line of code handles all the crazy complexity of making a web request. It just works. Next, we want to give our saved file a unique name so we don't overwrite anything. For that, we turn to our built-in datetime module. We ask it for the exact time, right now, and use that to build our file name. Simple and effective. And finally, the data we get back from GitHub comes in a format called JSON. So we use another tool from our standard library, the JSON module. It knows exactly how to take that data and write it cleanly to a file for us. And there it is, the final result, a file perfectly named with the data inside. This is it in action. We combined an external package from the community with 2 modules from the standard library and built a useful program in just a handful of lines. It's like taking the wheels from a Lego City set and the wings from a Lego Star Wars set to build something totally new. So we've gone from a single file to a whole global ecosystem. From one Lego brick to an infinite toy store. The system is there, the tools are ready, and the possibilities are, well, they're pretty much endless. The only question left is, what are you going to build with them?